Right, good morning. Today we are starting section 3.1, quadratic functions and their applications. Alright, let's first understand what the word quadratic means. Quad in Latin means square. Usually in here we use for 4, but this means square. In these functions you must have a square somewhere, and that's right here. So basically I call these functions square functions because they start with a square, and you may have two more terms following the square, but these are optional. So what makes a quadratic function really called quadratic is that very first square term. You must have it present. The other two are optional. So the most infamous function we already know this function, have seen it a lot, is x squared. This is the most famous quadratic function. Well, again, do we expect to see all three terms together? No. Having the first term is enough. And we have variations of this. You can put 3, you can put 1/2 in front. I mean, you can put any number in front. It's just gonna be wider or narrower. And this is the most well-known quadratic function. But can we have more terms like x term, several x's like 3x, and a number at the end? Sure. But these are optional, not required to be called quadratic. But this is the standard 3-term quadratic function. You pretty much all the time in this section see all three together. Alright, so quadratic functions mean square functions. We are going to investigate them and learn a lot about them, because in real life, in industry, these functions pop up a lot. We are going to make one example, one real world problem in the very end. But first we need to understand them mathematically. And our main issue is to graph, identify intercepts, and identify axes of symmetry, maximum and minimum of them. This is our main issue in this section. But let's first talk about one very important form this quadratic equations can turn into. It's called vertex form. Okay, well, what is this form called then? Let's name this let's call this a name. I want to call this standard form. But loosely, informally, I want to call it useless form, because it's really useless. I can't get any one of the informations I counted earlier, like vertex, maximum, minimum, intercepts, axis of symmetry. I can't find any of this information from this given form. Standard means no information. Then what do we need to do? Our main task in this section is, once this is given, can I make it a vertex form out of it? And yes, we can. Yes, we can turn it into vertex form. I call vertex form also very useful form. This is the real form we like. So this is the useful one. Alright, what does that form look like then? It starts with the same a, so these are common. You see, it's still a and a. So whatever number your square function starts with, like 3x squared, that 3 comes in front. And then these, let me compare once. Let's clean this and compare. And then in the standard form, I observe how many axes, how many spots with axes do you observe? 2. Here you have only one spot, here. Kinda these two are packed together under a square. You are packing those two separate x locations into one, and you are making an x and a number here. So there is a number coming up next to x. That x minus h, once you expand it out, it's going to split into two x locations. So those two x's are combining into one pack under a square. And finally, this number is gone and there is a new number showing up. So the only thing that remains the same is a. The number in front stays the same. X is double X turns into single X. And there are two new numbers, H and K, coming up. Those H and K are not in random numbers. Once you get them, they will, and pair them up, it's going to form something called vertex. What's the meaning of vertex? Vertex is when you graph these quadratic functions, we always get a shape called parabola. So the shape of quadratic functions are always called parabola. There are two shapes possible. One is two arms going up, so it has a minimum point or very deep down point, or two arms going down, upside down U, upside down parabola, and then we have a maximum point. These 2 points are called vertex. This is called vertex, and that's called vertex. But I call it seed. Why do I call it seed? Because it looks like this is a seed, one round seed, and two branches of a plant popped up there, right? Two branches are growing and growing up, or two branches are growing and growing down, correct? So I call this vertex form seed form, because you can read the location of the seed. This is the seed. Once you know the seed, you know how your plant is going to grow up or grow down. So seed is really the core. Most important part in all questions is reading, getting that seed. Once you obtain the seed, you have the whole plant. Okay? So, again, the tasks we're going to do today is, you will always be given this. You will always be given this. We are going to turn it into vertex form, or I call it seed form. Once you get the seed form, you're gonna pair up these two numbers to read the seed. Once I know the seed, I can graph it. I can get its maximum or minimum. I can get its intercepts and everything. Okay? All right. Couple more details though. When do these arms go up? Or this is a regular U shape. When does it happen? It's written here. When you have that beginning number in front is positive, more than 0, like 1, 1/2, they're all positive, or 10, then we have a regular parabola shape going upward direction. If the number in front is less than 0, negative, then those two branches from the seed, emerging from the seed, are going down. So I know the seed, I know the number in front, then I have the picture. That's it. Okay? How about the axis of symmetry? This number, the first coordinate of the seed, in other words, x coordinate of seed is here, and the x coordinate of the seed is here. There is a vertical line going up and down during that at that location H. It's called x equals H line, because any vertical line has x set it into a number equation. It's called axis of symmetry because you have, it's kind of, this line slices your entire parabola into two equal halves. Look, this half and that half is equal right between them. They are symmetric. When you fold the paper along that line, those two branches just coincide, overlap, right? Same way here, the left piece and right piece are symmetric, identical, equal halves. When I split apart this parabola along this x equal H line. Okay? Alright, just take a moment to digest all this information, because I have counted so many new stuff. And let me know if you have any questions. Again, standard useless form, into vertex, we need to change this, make the change. And that's a good procedure, solid procedure I'm going to show you. And from this new form, useful form, seed form, you will read two numbers and form your location of the seed or vertex. And you will determine the shape going up or down and graph it and find more data like intercepts, max, min, and axis of symmetry. That's pretty much it. Okay? Alright, we're starting with our first question. And these questions, well, I mean, it looks like we have only 6 questions here. They have each question, look, count the parts. 8 parts. Okay? So these questions are substantial. They are huge questions. However, number 2 is a real one. Real standard question. Now, this one is kinda easy. Do you have, when you compare the equations given and tell me why number 1 is easier than the real question number 2? Compare the equations. Any ideas? Why is number 1 kinda easier? Chris?
It's already in vertex form.
Yeah, look at this. This is kinda A, this is X, this is the number H under a square, X and a number packed under a square, and this is K. This is already cooked dinner for you. All you need to do is open your mouth and eat it, right? This is ready, already in vertex form, seed form. So this question is gonna take half the time than this one, because this one uncooked food. This is in standard form. How do I know it's standard? Because X's are separate, 2 locations. They are not packed under the same square. Got it? So we need to first cook this meal, then eat it, and answer 8 parts. Alright, let's start serving this meal. I told you this is already in vertex form, seed form. You need to first determine in part A whether the graph of the parabola either opens up, upward direction, or downward direction. Which way?
Down.
Ashley says it's down because this number is less than 0, negative, downward is the right choice. Because A is negative 3, which is less than 0. Okay? So far so good, huh? Any questions? Perfect. Part B. I told you this is already in vertex form. I mean seed form. You can read the seed here, location of the seed. All you need to do is 1, 2, 3. There are 3 numbers here. This is A. Ignore that. There are actually 2 left. You're gonna use those 2 numbers and form the vertex. Anyone wants to say it? Come on. Intuitively, what do you think? Which one do you think you're gonna pick as X value?
-3.
Yeah, the number next to X should go for X coordinate of the seed. However, it's not -3. Yes, we always take opposite of this number, which is +3. Okay? Always opposite. What if this was a +3 and I would take it -3? Alright? What do you think about the Y value?
Just 12.
It's -12. Are we gonna take opposite again?
No.
No, we're gonna take it as it is. The second one is as it is. Whatever this number is positive, it's positive. If this would be negative, I would take here negative. But first one is opposite. The second one is original one. That's it. It's just reading. Part B is just reading those numbers correct way. Alright, next. What is part C? Determine the x-intercept. This is nothing new. In one section in chapter 2, we have learned how to find the intercepts of graphs of equations. To find x-intercept, I need help. What do we do? Who remembers it?
Set y equal to 0.
Yeah, it's always the opposite variable. Set the opposite one, y into 0. Okay, where is y? This guy is y. So I'm going to set that into 0 here. Okay. And then solve for x. Alright, to solve for x, I need to isolate x and all these numbers. 1, 2, 3, 4 numbers. I need to get rid of all of them, but which one is first? You first get rid of this one. This is second. This is third. And this is fourth. In 4 steps, we will get rid of these numbers. Starting with the far to closer. This is the farthest one, and this is the next, and that's later, and the closest one to x next to under the same square is 3. So that's like the bodyguard. We're gonna get him last, okay? Alright, how do you cancel 12? By subtracting 12 from both sides, right? You get negative 12 equals negative 3 x minus 3 squared. Now, second guy is minus 3. How do I get rid of minus 3? Adding 3 both sides. Shall we add? No, it's multiplication. We shall divide. And that's, this thing is 3 goes into 12 how many times? 4. Okay, 2 guys are gone. There are 2 more to wipe off. Who was the third guy? How do you cancel a square? Do we divide by 2? We take square root. And this is the moment you guys make a lot of mistakes. And I say square root of 4 is 2. Square root and square cancels. And I have minus 3. Where's the mistake?
It should be plus minus 2.
Right. When you introduce square roots to both sides, put plus and minus to the number side. Where is the number? Left side to that side. And finally, I need to kill the last number x to x, next to x. How? Add 3. Add 3 to both sides. Alright, there are 2 cases here. You can have x something. First, you take the positive option. 3 plus 2 is 5. Then you take the negative option, the second case. 3 minus 2 is 1. Alright? So these are the x coordinate, or 5, 0 and 1, 0 are the x-intercepts. Correct? 5 and 1, which I found, is actually the x-coordinates of the points. Why the y's are 0? Because these are x-intercepts. They happen to be on x-axis. Anything on the x-axis has y value 0. Alright, we're almost halfway. Any questions? Alright, let's get part D, which is y-intercept. For x-intercept, you set y into 0. For y-intercept, guess what you're gonna set into 0? X. In this formula. And this is always easier than the x-intercept because you don't have to worry about moving things around. This thing is gonna be 0. So we have y equals minus 3. 0 minus 3 is minus 3 squared. And that makes, this happens to be, what is minus 3 squared? Minus 3 times minus 3 is 9. 3 times 9, negative 3 times 9 is negative 27. And we have a 12 on the end. And it makes minus 15. Good. So y-intercept is negative 15 comma 0. Agree? No, it's the other way. 0 comma negative 15. Great. Now we are exactly in the halfway. Let me again put things we found so far so you don't lose them. This is y-intercept. These are x-intercepts. This is the seed. We determined it's downward. 4 results. That needs to go into our homework palette in the answer box. Okay, part D. What is part D? Let's read it. No, this was already D. We are in E. We are gonna sketch it. Interesting. Okay. Of course, you need to have X and Y axis here. Okay. How? It's no brainer because you have two options. This thing is a U-shaped parabola or upside down. We already decided that, right? Which shape are you gonna pick? Is it U, upside down U?
Upside down.
It's upside down because of part A. We know the branches are going down. It's downward. So I know it's a downward shape. I will just make a downward shape here anywhere I wish. No, I need to know where the seed is. Find the seed, go down. Find the seed, go down. I don't know. Where is the seed? At 312. So if this is 1, 2, 3. 1, 2, 3, 4, 5, 6, 9, 12 should be up here. Here you are. Here's the seed. Okay? Let's complete the picture then. We go down. Alright, question is, where do I hit the y-axis? Do I go wide and hit early, or do I go narrow and hit a lot lower? Where do I hit x and y's? Well, answer is here. You hit the y-axis at minus 15. Wow, it's not even this low. You need to go all the way here This is minus 15. You need to cross y-axis right there. How about x-axis? You need to cross x-axis at 5 and 1. So let's mark this. This is 5 and this is 1 and this is minus 15. X-intercept, y-intercept. Those three are the locations I'm going to make. Lost one of them, but it was somewhere here, right? Okay. So from this point forward, I go down, down, pretty much down, and voila, cross that purple point, down and down, go down. Okay. This is 3, this is 12. Alright, that's it. That was the picture. What is F? Any questions? Determine the axis of symmetry. You will just tell me a vertical line equation for this. What is the line equation that goes right between those two branches? X equal what? 3. It's this number, x coordinate of the vertex seed. G. Determine minimum or maximum. Okay, you cannot have both. You either have a maximum or minimum. And look at this picture, please. E. Look at the picture in part E. Does this thing have a maximum or minimum? Maximum. It has a peak point, summit. And what is that value? 12. I mean, how high you guys are above the ground, this mountain? It's 12. But where does it happen? If I say, where is the geographic location? Is it in Denver? Is it in India? Where is the location? It's happening at x equal 3. Height is 12 feet above the ground level. Maximum is 12. H, you're going to find domain and range. Okay, good news. Domain. All quadratic functions have the same domain. No matter what equation you have, all square functions or quadratic functions will always have the domain. Domain is the set of x values you can pick and enter into this function, and it's gonna give you a good number, not undefined number. What do you think that domain is? In other words, smash all this red into the x-axis. What is the image? And you press it down to x. These arms are widening and widening all the way, going down but getting wider and wider. What is the domain? Yeah, it's all numbers. You can enter any number you wish into this equation, and it will always produce a new number. There are no bad numbers that can make this function sick. No, nothing. Okay? However, range is not like that. Range varies from a quadratic function to another. Range varies. And how do we find range again? From earlier sections we did that. For domain, you're compressing into x-axis. For range, guess which axis we are going to compress it into? Which axis? No, y. Domain is x, range is y. So push this, take two plates and smash this picture to y-axis. What's the image gonna be on y? Right, it's going to form, this point is going to come here. It's going to form this blue region. Right? So how do I read it? Is it 12 to negative infinity up to down? Like that? No, in an interval notation, you need to always go from smaller values to big. Negative infinity is smaller than 12. So it needs to be negative infinity first up to 12. Shall we count 12 in or excluded? Bracket or parentheses? So bracket, because this maximum value creates this value, right? I can say range always, one end will be always a bracket, the other end will be either positive infinity or negative infinity with the parentheses. Okay, I think we are complete. All you need to do is take this 8 parts information you found and carry it into the question. Opens down. Vertex is 3, 12. How many x-intercepts we have? With 2. They were 1, 0. And 5, 0, right? Y-intercept was 0, negative 15. This is the way you're supposed to do it on paper, then transfer your answers. Picture we found was, which one was it? Seed was at 312. So it is this, right? 312 is here, A. Axis of symmetry was x equals 3. The function has a minimum, no, maximum. Maximum value we found was 12. It's not asking where, just enter the maximum value. In interval notation, the domain was, it's always standard in quadratic functions, negative infinity to infinity. Range was negative infinity to 12 with a bracket. There we go. All done. Okay. I told you this was the easier one, and even the easier one took our 15 minutes. I talk a lot, so I can do faster here, but in 12 we need to first get the seed form, and please, if you get the seed form wrong, all 8 parts will be wrong, and you will pretty much lose almost every point in exam or homework. So take your time to do seed form slowly, and it's very essential you listen to me today and understand this here. If you don't get it, you will lose everything here. Okay? Now how do we get the seed form? I'm going to do this step by step. So let's get vertex form first. I'm not starting A yet. This is the pre-step, first step, step 0. We need to get the vertex form. Is required. So for this, I start with copying that equation. And first thing I'm gonna do is check the number in front of x squared. If it is 1, you don't have to do anything. But what is the number here? 3. And we are going to first factor a 3 from everybody. Okay? So I'm going to factor 3 first. Well, not everybody, these two guys. So separate this 11 here. We pretty much don't use this 11 for a real while. It keeps going down and down, 11, 11, 11, until the final moment. What we do is, I want you to factor 3 from these guys. Open a parenthesis. When you divide 3x squared by 3, and you factor a 3 from 3x squared, what's left? It should be only x squared. That's why I did it. I want to separate this 3. When I factor a 3 from 12, what is left? 4 minus 4 and x. Okay? So far so good? Okay. Next. And this is very important. This 11 always comes here, okay? Now, have you noticed I did something? I took some space after 4x. Some space here. So we are going to do a magic here. I want you to add a number here. Okay? But that number should not be just randomly picked. That number is going to be chosen in a way that when you expand x and a mysterious number, which is -2, this blue marked value should be the number here. Okay. Here, let me back up. We're gonna first exercise something. Do you guys remember how to expand this? So we are going into side and doing a side exercise. This has nothing to do with the question yet. How do you guys expand x minus 1 squared? We FOIL it, right? Okay. How do you FOIL? First, outside, inside, and last, right? F-O-I-L. FOIL is this. So we get x squared minus x plus 1, x squared minus 2x plus 1, correct? Now I want to try another example. X minus 3 now. X minus 3, I FOIL again. First, x squared, outside 3x, inside negative 3x again. It's always these two match. Outside is negative 3 times x, inside is negative 3 times x, and plus 9, it is x squared minus 6x plus 9. Now, do you need a third example? I think you guys are smart. Do you see a pattern between this number and this one. If this is -1, this became -2, right? And if this is -3, this become -6. What is the relation between these two numbers all the time? It's always double. Like if this is x minus 4 squared, its expansion will be x squared minus, tell me the number coming up, minus 8x, and then something, blah, blah, blah. How about if this was positive 6? It's x squared, what? What? Plus 12. It's always twice. Determine the sign though. Plus 6. So it's twice plus 6 is 12. Plus 12. And something. You guys are great. You found the relation between this number and middle term. Now I want you to try something else. What is the relation between this blue number and this red number? Blue, red. -1 turned into 1. -3 turned into 9. What is the relation?
Squared.
Squared. So -4 will turn into
16.
positive 16. Positive 6 will turn into 36. Okay? Now you guys are ready for the move here we are gonna make. I want you to figure out a number. We are gonna add a number here, but when these three were packed under a square, it needs to be a perfect square, x with a number here. Okay? Now my question is, what is this accompanying number? What is the number next to x first? Hint. What is the number coming up here? You need to go back from here, there, here, there. What is it? -2. Okay? It's -2. Okay. What do you think the number I'm going to add here then? It's going to be positive 4. Why? Because you always square this number. Alright. There is something missing though. Look. Track my moves from here to here. 3x squared minus 4x 11. 3x squared minus 4x plus 4 and 11. I just added one thing to the middle of the equation and I'm saying it's still the same c of x. Is it correct? Can you just change your mind and add something to the middle of the equation and expect it to be the same again? Does it happen? Is it fair? No. You can't do that. If you're adding something, you need to compensate, pay for it. So how can I compensate for it? Yeah. You either add to this side. What am I going to add though? I already gave you the answer though. Since I added 4 and it will be multiplied by 3 once you expand it, either I added to here 12 or I don't want to bring numbers next to c of x. It's going to make my life harder. If I added something to this parentheses, how can I compensate it if I don't want to add 12 to here? That's one way, but I don't prefer it. What's the other way? If you don't want to add to this side, you have something more weight on the right side. How can you take that extra weight off? Subtract. Perfect. We need to subtract that 12 after 11. Got it? Does it make sense? Why am I subtracting 12? Because I have artificially, with my will, added something and increased the balance. Now I have to keep the balance by taking off that extra weight. Okay? Alright. I know now you have a feeling you got it, but you didn't, really. So I'm going to back up and explain everything I did after this step again. Okay? Let's do it together again. What did I do? I took C of x here. Step 1. Take some space after minus 4x. There will be a number coming in. This is the same guy. Now how do I figure that number? By guessing the next step. In the next step, there will be a number here with these three is going to collapse into a square. I first guess what number I'm going to take here. I first guess this one. This is the step 1. I first figure out this number. Step 1. What is that number gonna be? Take half. Take half and get this one. And then from here I move into this question mark. This is step 2. How do I guess the question mark? What's the operation I make? What is it? From this number to here? Squaring it. I will square it. Oh, there you go. I found you. It's positive 4. Then what is step 3? It's not over. Once you add something here, you have broken the balance. C of x is no longer this thing. So you have to take off what you have added to that parenthesis from the end. So how do I do that? So I just subtract 4 because I added 4, right? Is that right?
No.
Why not?
Because you gotta take the frat number.
Right, because when this 3 and 4 multiplies, I actually didn't just add 4. I have added 12. 3 times 14. So it's not just 4 taken off here. We need to take the whole weight when you have triple it, which is negative 12. This is the complete steps now. Okay? Now, we need to bring these numbers after this. What is it? 11 minus 12 is? And mission accomplished. This is now declared seed form. I put it in a frame so I don't lose it because this is so precious. Vertex form. Why is it so precious for us? Because we are going to get the remaining 8 parts the question requires all from this equation. That's so precious for us. Got it? Shall we start? Now the question is starting. We haven't done anything about the question yet. Part A is now starting once we get the vertex form. Tell me. Oh, we already did. This is part A, sorry. So this has 8 parts again. The previous one is, they just changed part A, okay. This is part A, we found the vertex form. So part B. Determine x-intercepts. And you know how to do this. For x-intercepts, we set somebody 0. Who? The left side, C of x, or y. This is y into 0. And I get this. Alright, work it out on your own. 30 seconds. Okay. There are 4 targets we need to clear here. 1, 2, 3, 4. We start with -1. Add 1 to both sides. We have 1 equals 3x minus 2 squared. Correct? Second, divide both sides by 3. We have 1 over 3 equals x minus 2 squared. Third, I need to cancel that square. How? Take square root and do immediately what? Plus minus. I can't take square root of 1 over 3, so I'll just leave it like that. And add 2. There are 2 results. One, x is the positive choice. X is the negative choice. Okay, this is not necessary, but when I'm sketching the graph, I need to know whereabouts of x, roughly, estimated. So can somebody help me and take square root of 1 over 3 and add to 2, and roughly how much this is in decimal so I can locate it on x-axis? Come on, somebody with a calculator. 2 point what?
2.57.
Okay, this is 2.5. And this one is about 1.43 then?
1.42.
42 something? Okay. Alright, we know roughly where they are. But what is required is these two only. Not this. I need these two so I can plot them. Alright. Okay, that was part B. Now part C. Determine the x. Oh. I did C actually, right? Sorry. This was C. Now let's do part B here. What is B? It's on this side. Identify the vertex. That's easy. Anyone?
2.
It's opposite of this number 2. Actual number afterwards -1. Okay? Alright, so let's mark this. And this is already here. D. What's in D? Identify y-intercept. Set x into 0 to get y-intercept. So y equals 3x minus 2 squared minus 1. I set 0 in here and get 3 times, what is 2 squared? 4 minus 1, which is 11. 0 comma 11 is the y-intercept. E, right? Am I doing it right? Sketch this thing. I'm starting with intercepts 0 comma 11 y-intercept. I will say here. Oh, that's positive. I need to mark here. No. Alright, I'm going to choose a smaller scaling. I will mark here. Where is x-intercepts? 257 and 142. These are x-intercepts. Alright, seed. Where is the seed?
2, -1.
So it's pretty much here and there. Start with this seed. Which direction shall we go? Down? Is it down? Look, all the intercepts are up above the red point, right? That's the first reason. What's the second reason why we need to go up?
Because it's closer.
Yeah, this number here is past the 3. That means it's a narrow, 3 is a big number, narrow, skinny parabola. Okay, sorry about my poor sketching skills, but alright, almost. Any questions so far? F and G. 2 more parts and we're done. F says axis of symmetry. Anyone? What is this vertical line passing through right between these 2 branches? It's x equal what?
2.
So always this guy, x equal 2. G? Write down the domain and range. Domain is always standard. It's a no-brainer. It's negative infinity, infinity. Range, the O is different all the time. This one is,
Bracket -1.
right, we start with this bracket -1. Go all the way up, right? There you go. So it is I read this one. This is past the infinity. Infinity to -1. It's -1 first, from top, bottom to top. To infinity. Any questions? Once you get the vertex form, it's smooth sailing afterwards, right? All 8 parts like that. It goes very fast. Now we need to enter all this into the question. Vertex was -2 comma, what was it? -1. No. Oh, it's not saying vertex. It's saying vertex form. So you need to write the entire form. Right? Now vertex goes here, 2 comma -1. It has how many? 2 again. Sometimes you may have no x-intercept if the vertex is up on the first quadrant. X-intercepts were 1 over root 2, root 3, or square root of 1 over 3 0. What was the other one?
There's a 2.
2.
It's 2 plus.
2 plus. Alright, I hope it likes it. Okay.
2 minus another one.
Yeah, I forgot to. Yeah. Alright, once you choose, go all the way to the left with arrow keys. I hope it's right. There you go. Okay, y coordinate is 0, 11. Is it positive? Yeah, positive 11. And we choose which shape? C, right? Symmetry is x equals 2. Oh, what is that? Have we skipped this part? I think we did, right? What part did we skip then? F, G. There was an H. Oh, we skipped G. Oh yeah, it has G and H. This is H. G, does it have a minimum or maximum? Which is, yeah, this y value of the vertex. Y value of the vertex is the minimum all the time. Has a minimum. I think it's gonna ask what it is. Yep, -1. And domain. Negative infinity, infinity. Range is -1, comma, infinity, parentheses, check. Alright. Looks smooth. Kinda everything goes okay, but no. If you're doing your own questions on your own, you will get frustrated. Because I bet you're gonna have a lot of mistakes. It's okay, I mean, first couple times you must have mistakes actually, it's quite normal. Go check this step first. You probably messed up something. Come back and watch how I'm doing it again. And then, once you get this right, you shouldn't have any problems answering the parts. Usually the mistake happens in this parentheses and creating this third number and taking off a number here, subtracting something. Okay? Alright, we stop here today. This is a long subject. We're gonna continue on Monday. No, not Monday. We have no class, right? It's Tuesday.